interesting session lined up for you. We have with us three distinguished speakers from Fujitsu System Integration Lab, Ryusuke Masuoka, Toshi, and Koji. And they will be sharing on seamless CTI sharing and utilization. So before I proceed, before they proceed with the presentation, let me remind everybody, if you have any questions, please put them in the Q&A box so that the speakers can take them up later. So now over to you, Ryusuke.
Okay, thank you, Adri. All right, let's begin. Hello, everyone. Actually, the title is Where Human and System Defenders Share. We are going to talk about seamless CTI sharing and utilization. We are the party of researchers from Fujitsu System Integration Labs. I am Ryusuke Masuoka, the visionary of this project, and I'm going to play the role of commander in this presentation. Toshi is Toshitaka Satomi. He's the architect of the platform for this project, and he's going to be the SAPR or combat engineer in this presentation. Koji is Koji Yamada. He's a former CERT member of Fujitsu. He's going to be the ground soldier in this presentation. We all are voting members of Oasis CTI Technical Committee. Okay, please let us start the journey. So the journey looks like this. Road behind us first, then what happened in the sea of IOCs. We will tell you where we found the treasure and the signpost we found on the way. Then the bridge we built over the sea of IOCs. And then we're going to give the show or demonstration. And then finally, the message to take for you to take home. The first, road behind us. A long time ago, about 30 years ago, a journey with cyber threat intelligence or CTI started. Initially, only a few very limited people from a secretive agency had access to their precious IOCs or indicators of compromise. Then those IOCs like IP addresses are shared within a wider organization for their threat hunting. Eventually, communities like ISACs, ISAOs, and open source and commercial CTI providers appeared, and people now have access to abundance of IOCs. We have come a long way since the initial time, but somehow we found ourselves drowning in the sea of IOCs, surrounded by too many IP addresses, domain names, malware hash values, etc., etc. Well, what happened, Koji?
Okay, let me explain. Hi, everyone. I am Koji Yamada. I was an incident response team member being engaged in monitoring security alerts from our cloud infrastructure. The team has been collecting IOCs from open source and also receiving IOCs from several ISACs. I guess many of your organization does this too. However, are we really making good use of IOCs? I'm afraid we are all drowning in IOCs. I believe any organization would agree that information is better to have than not. the CTI sharing system has become much more developed. At first, it was mostly emails, but gradually, we have started a large amount of CTI sharing on the system. A few years ago, I tried to utilize the CTI to enhance security monitoring. What I learned was that most CTI was IOC only and lacked the context needed for action. It was very difficult to take appropriate, subsequent actions without context. Suppose you receive an IOC of a dangerous IP address and decide to block that IP address for your customer. However, the address has been reused, and you upset the customer who was using it for their business. You could have made a better decision if you had the contextual information like the IOC's freshness. So where is context? So many analysts are regularly reading security blogs every day and sharing information on social media and emails to learn about the latest cyber attacks. This is exactly the kind of treasure we should be utilizing along with IOCs. But we found that it doesn't work right away. Such human CTI is written in natural language. It is tough for computers to interpret and not amenable to use it along with the massive amount of IOCs available now. Human analysts need computer support to deal with a large amount of data and information. However, unlike IOCs, mass sharing and distribution of human CTI contents in a format easy for systems to handle has not been considered. On the other hand, it would be much easier for various types of systems to consume human CTI in mass if it is available in a structured format. Ryu will introduce a new concept to deal with the situation. Ryu?
Hi, okay. Thank you, Koji. So here the signpost we found on the way, or actually we created this to summarize the situation. So as for IOCs, the full cycle of generation, sharing, and consumption in mass has been established. However, for structured contextual CTI, we see generation and consumption in some local systems, but we see very little of sharing, if not non-existent. We believe we have to change the situation. So we decided to build a bridge to where human and system defenders share. We call this bridge a Seamless Threat Intelligence Platform, or STIP. The core idea is very simple. Everything in social media posts, emails, anything through taxi, which is a CTI communication protocol, or mails or PDF files, local or on the web, everything consumed by STIP will be turned into structured CTI, which is STIX data, stored in a single CTI database built on top of MongoDB. STIX is a structured CTI format being standardized by Oasis CTI-TC along with taxi. Then everything out from STIP will be converted to whatever format appropriate for each outlet from STIX data on the fly. So SNS or social media timeline, graph graphical representation of CTI, emails, or to the taxi outlets, ticketing systems, orchestrators, security appliances, PDF files for to share CTI outside of STIP, MISP, Slack, and so on. In the later demo, you'll see how posts to social media or SNS turned into sticks, and then the sticks data turned into PDF. Also, sticks data shown graphically for analysis, and integrations with a couple of tools. As mentioned, the concept is simple, but it was not without challenges. Actually, there were many challenges to build this bridge. I'm going to list two major ones here. The first one was semantic mappings into sticks. So social media or SNS posts or other systems which are not sticks compatible, or even sticks 1.2 to 2.1. There are many semantic gaps that we needed to fill. Also internationalization and on and on. The other one was computation resources or costs for parsing sticks 1.2 in XML and 2.1 in JSON was pretty expensive. This is kind of important consideration for us because we need to do a lot of on-the-fly conversion from sticks to other formats. So we decided to use a cache mechanism based on RDB, MySQL to be exact. So those challenges are mostly dealt or solved by Toshi, he's the one who is going to give the show or the demonstration. So Toshi, floor is yours.
Okay. Please wait to share my desktop. Okay, hi, I'm Toshitaka Satomi, the server. I'm going to demonstrate how great a structured context CTI is. Today, I received a threatening email. I would like to talk about this. Incident. I decided to post it on the SIP where members of some either gather. Name me is the title and content of the post. Fill the title and content. All right. The content includes IOCs like an IP address. It also includes a Bitcoin address as a hashtag, threat actor name, in this case, Funky Mosquito, and CV number. When finished, click this post button. The dialog box appears. The dialog box shows the result of CTI element extractor. The CTI element extractor searches CTI element candidates like indicators of compromise, TTP as a CV number, and a threat actor name from my post. Let's keep all of them. I'll click this compose button to finalize it. Wait a minute, it's now loading. My post has appeared on the top of the timeline. SZIP has automatically converted my unstructured post into structured 2.1 format and accumulated into the single stick database along with CTI from other humans and systems. That is, human CTI and system CTI are merged into the same single stick database. Okay, let me show you the 6 file just created from my post. Wait a minute. Let me bring in the window just popped up. Okay, this is a 6 file. As you can see, the 6 file is version 2.1, and with the CTI elements like IP address and domain name and malware hash value in a structured manner. I will skip it, but one can find title and content text towards the end as well. We can also download this information as PDF. Okay, this is very useful in case you want to share the CTI with the people without access to this SCIP. All right. This bell has turned blue, meaning new comment for my post. You check it. This comment is from GV Concierge, which is one of the chatbots of the SCIP SNS module. GV Concierge has automatically searched CTI related to my post in the 6 database and reports the results in this comment. Let's see what GV Concierge has to say. Clicking the link leads us to the CTI graph analytics view. All right. This graph shows the CTI from my post in links and nodes. This left side column lists the CTI pieces related to my post. Let's see what it means. Another graph has appeared. The two graphs are linked through two fat red lines. Both ends of the red line have the same value. In this case, this one and this one. The both nodes have the same hashtag value of the Bitcoin address. There is another CTI related to my post. All right. It adds useful information like another CV number, how to deal with this attack. These three pieces of CTI are different. However, these red lines indicate the three posts explain about the same attack. All right. I'll pick a few examples of SCIP integrations with other tools and quickly demonstrate them. The first one is with Jira. Jira is one of the most popular ticketing systems in the world. I judged that letting communication with the domain continue is too dangerous and decided to cut it off. I'll ask SOC operators to add the domain name to the blacklist via Jira. I click the Jira link in my post. After a few seconds, the Jira window opens. Now loading the Jira page. All right. This is a Jira page, and this page contains my title and post with PDF, CSV, and the 6 file. I assign an operator and ask him to deal with it. The second one is with MISP. MISP is another open source threat intelligence platform. By clicking the MISP link in my post, I can share the CTI to the MISP community specified in the setting in advance. The last integration is with Slack. In fact, SCIP has been communicating with Slack. As you can see here, my post a few minutes ago is already on the timeline. Okay, to summarize, SCIP enables us to generate structured context CTI from unstructured information like natural language text. SCIP also consumes, shares, and utilizes it. Through structured contextual CTI, SCIP serves as a bridge over the sea, drawing many in the webs of non-contextual IOCs Thank you for watching the show. I'm Toshi, the staffer. Back to you.
Okay, thank you, Toshi. And I'm about to share my screen as well. Okay, thank you. And so the message for you to take home. So generation, sharing, and consumption flow of IOCs in mass has been established. That's good. But now is the time to establish such a flow of structured contextual CTI in mass as well. So please join forces with us in this endeavor. Here is the ticket to where human and system defenders share. SCHIP is available as open source software on GitHub. I hope you enjoyed the journey with us. Thank you for attending this session. Back to Adili.
Yep. Thank you, Ryu, Toshi, and Koji for the very interesting presentation. I really love, and a few people also love the references made from Edinburgh. I believe
and also
you have
Montreal as well.
And Montreal as well. I believe there is a poll that you want to do before you go into the Q&A.
Oh yeah, yes.
Yeah.
Yes.
Josh, can you help us with the poll?
So please fill if you can. These are questions about how you are dealing with a CTI. And
yeah, if everybody can help fill up the poll or do the poll for us.
So do we wait for the poll to finish? Or do we go for Q&A?
Yeah, maybe we can go for Q&A for the time being. Can you see the Q&A questions in the box?
Okay.
All right. It's all from Mark, so you can take it up.
What are some, from Mark, what are some examples of human CTI you refer to as security blogs and reports and etc. in the slide? So, we refer to security blogs by security vendors like FireEye, CrowdStrike, and so on. Sometimes it's in a texture form, and sometimes it is in PDF. SCHIP actually kind of grab those security blogs or PDF and then do the same kind of parsing to extract CTI elements and put into the SCHIP into the STIX database. So yeah, that's what it is. And okay. Why did you pick STIX as the CTI format to use for your system? So people might think that STIX is for IOCs like IP addresses and so on, but actually being a member of Oasis CTI TC, STIX is a kind of very expressive standard for CTI, and also it is from 2.1. There is a customizable element as well. So actually, Bitcoin address was we use customizable object to include it, and so on. So STIX, we picked STIX because it is a standard and also expressive enough to for our purposes. Can you explain how? So can you explain how you add context to CTI on the SCHIP platform? So yeah, so SCHIP kind of extract from the CTI elements, and in the case of text, then add add them in a structured manner. If it is already in a sticks, then it is kind of goes into the sticks database. Integration to Hive Pro. So it's a kind of statement, but we haven't tried it. Integration to Hive project. We haven't tried it yet, but I think that's something that we might do it in future. Then is why not use MES app as a repository and sharing platform? Yeah, that's another. That's kind of possibility, a strong possibility, and but initially we started this project. MES was not a kind of it didn't have enough capability, or kind of it's not it was not using a sticks, so so we decided to go for kind of integration with MES. Rainer, the question is, does SCHIP allow typical indicator management tasks like deduplication, expiration, and enrichment, etc., etc.? So that kind of aspect is still weak, to be honest with you. But we do have enrichment capability. Actually, we use attack and also Circle LU database to enrich some of the indicators, as well as CV, like a TTPs, like a CV information, and so on. I guess I have managed to deal with all of them.
Yeah, I think there is one more, the last
one more, sorry.
Yeah. Can STIP process random RSS or PML, AROM, or any XML-based data feed?
Okay, so right now STIP does not, but I think it is a matter of adding adapters to them. So yeah, that's the answer. Thank you for questions, by the way.
Yeah, yeah, there were great questions too. Thank you for answering them. I think that is all the time that we have, and the results of the poll is also up there, I think, for folks to have.
Oh, cool.
Oh, cool.
Yeah.
Thank you, guys.
So yes, so I think we can wrap up this session. Thank you once again to all three presenters. Very interesting and useful presentation, I think, for folks. And I think we all have greatly enjoyed it. Thank you all also for attending this session. I hope to see you in some other sessions today. So goodbye, everybody, for now.
Goodbye.
Bye.
Thank you very much.
Bye. Thank you for attending.